Hi, welcome to our presentation for the NeurotechX 2020 competition. My name is Patrick Larose and I am part of the student club SynapsÉTS from École de Technologie Supérieure. Around 20 members are part of SynapsÉTS. We work together on multiple projects in neurotechnology and biology. Our projects are named MIXA, Unity, and EXO. With the project MIXA, we focus on acquiring signals from the body like EEG, EMG, and ECG signals, transferring the data in real time through the internet, displaying the data, and analyzing it. The project Unity works on developing multiple games using the software Unity. The main goal is to use signals from the body to trigger certain actions in the games. Our last project, EXO, works on building an exoskeleton for the lower part of the body. Every year, we participate at a couple events. Last year, we went to the School Open Day, the Student Club's party, and to the LAN-ETS. This allows us to meet new students. We also went to the MAIN, the Montreal Artificial Intelligence and Neuroscience Conference. The project we are presenting is a mix of MIXA and Unity. We created a game using the software Unity in which we use an EMG signal to interact with the game in real time. To achieve this, we needed to find a concept that was working correctly while being both fun and simple. After a few iterations, we came up with the idea of a ball moving in a 3D environment to find targets. We wanted to use the cloud for many reasons. Being able to run our applications on many devices opens a lot of possibilities, and we can share more interactions with each other. EMG means electromyogram. This technique picks up the electrical signal from the muscles. We can evaluate the tension in the muscles by measuring the voltage of the signal. Now let's talk about the technical aspects of the project. We'll start with the Myoball muscle sensor. The board we are using was made by SparkFun. We just have to connect its 3 electrodes on the biceps to get a filtered signal. The voltage we're getting from the Myoball muscle sensor is between 0 and 5 volts. The Myo is connected directly into an Arduino built with an analog to digital converter. The Arduino picks up the analog signal from the Myoball muscle sensor, convert it into a digital signal, and then send it back to a computer via serial port. With this setup, we can get our EMG signal on a PC in real time. Now, we just have to send the signal to the PC that runs the game. To do this, we use a streaming platform named Kafka. We chose to transfer our data with Kafka because it allows us to create a real-time data pipeline that can be read by any device that has an internet connection. Also, Kafka can support a very large dataset and is pretty easy to use. Our main goal was to be able to transfer and read the data in real time through the internet to have a smooth experience in the game. Rotating obstacles are in the way of some targets. The angular speed of the obstacles is changed with the values of the EMG signal. It is possible to have 2 players in the game via the internet. The first player interacts with the Myoball muscle sensor, creating the EMG signal, while the second player moves the ball in the game. To reach all the targets, they must cooperate and slow the obstacles at the right time. The first thing we had to do was to set up Kafka on a server. We use our student club server that is connected to the school network. Our cluster only contains 1 server, but it is enough for this project. The Kafka service is always running on the server, so we can connect our application to it at any time. So, from the PC that is connected to the Arduino by serial port, we run a Python script to connect it to the Kafka server. The PC will have the role of the producer, which sends the EMG signal on a topic of the Kafka server. From there, the data is accessible for any device that has an internet connection. To read the data on the PC that will run the game, we also use a Python script. The script reads the data and then transfers it to a precise port using the UDP protocol. This way, any application on the PC can have access to the data in real time. As for the game, it was built using the game engine Unity. The code is written in C#. The concept of the game is simple, adapted from the rollable idea. Our game features allow a quick feedback of the player's actions. To read the data with the UDP protocol, we use .NET native classes. The data is then read, processed, and transformed to change the play area. A particular attention was given to the threads of the program to link the physical engine threads to the network thread. To improve the player's experience, we worked with the two most used senses, sight and hearing. We use high-quality texture for the game, with a 4K resolution for the board with its stripes and wood grain to help the player see the movement of the ball. Also, there is an auditory feedback when the ball hits a wall. Now, let's test the game. On the left part of the screen, we see the EMG signal is acquired from the Myo, transferred on PC from the Arduino by serial port, and sent to the Kafka server on Jacques' computer. On the right part of the screen, we read the data on my computer and send it to the port 5020 using the UDP protocol. As we can see, the value is increasing when Jacques is flexing his muscle. On the top left of the game, we can see the UDP port being used and the value read from it. We can change that port if we want. In the middle of the screen, we have set up a manual override for testing purposes and to ease the development of the game. On the top right, we display the number of targets acquired on this level. Now, let's play the game. We'll start by picking the targets. We can see the count going up on the top right of the screen. When Jacques flexes his muscles, the bumpers slow down. For the last target, Jacques must help me by slowing the bumpers to let me through. We've encountered some challenges along the way. We had to think about the best way to have access to our data in real time in the game. The difficulty was to synchronize Unity's main thread with another thread that was reading the data. A new thread in Unity was reading the UDP network socket and stored data. Meanwhile, a Python script was connected to Kafka, sending data to the port via the UDP protocol. Another challenge was the setup of the server. We managed to set it up in a secure way and to install Kafka correctly on the server. But the most important challenge we faced was to work entirely remotely. We had to adapt our methods to distribute the tasks evenly between the members and to work together as a team. We would like to thank our school, École de Technologie Supérieure, for all their support and for allowing us to keep our activities going even through the global pandemic. We would also like to thank you, NeurotechX, for organizing this competition. It motivates our members to keep pushing themselves and to be proud of their accomplishments. Synapse is already preparing for the next competition in 2021. We would like to participate both in the fixed challenge and the open challenge. We will keep our hard work and deliver even better projects. You can find all the information related to the project on our GitHub. Thank you for watching our presentation.